Okay, mic check. Can you hear me, guys?
Yes, sir.
All right, cool. Hey, I just saw you guys a while ago. It felt like 5 minutes ago. Literally. Oh man. Um. Okay, so today we are. There we go. All right, guys. You can see my screen okay and everything, right?
Yes, sir.
Okay. Okay, so today we are featuring a presentation and some unveiling of some new topics. But tell me something, what's happening there in studio for you guys? What are you doing now in studio?
Analysis presentation on Friday.
Oh, you have site analysis presentation. This is for housing, right? Okay, cool. I think at the beginning of the semester, I'd ask who was planning to use Revit in their final project. Sure, I didn't record who answered, but in any case, is there anybody that is still feeling doubtful of using Revit to produce their final project? This is if you are feeling doubtful. Give me a thumbs up if you're feeling doubtful. No? Okay. So I can assume that most people here are feeling confident with Revit to use it for their production. Right, Danielle? Confidence is shining?
Yes, sir.
All right. Well, a part of our mission in computing is to support you guys in studio. So I would like for further down into the module, we start doing some examples of things that you will need in studio. So some things like generating a automatic floor plan key, like a key of the different spaces and the areas of the different spaces and things like that. I try to fit those in as class activities, and I think that you guys will find it helpful because you guys have to do like units, right? It's still multifamily that you do in third year, correct?
We're not sure if it's multi-family or single family, or maybe townhouses. But
Okay,
I guess we're
okay.
gonna find out that on Friday.
All right, cool, right. All right. So that will be our aim. But as it is now, we're gonna go through our presentations, and we're going to get through that first. So with that said, topic 3 and topic 4. Generally, I see
Yes,
you're
sir.
rearing to go.
Ready.
All right, so as usual, we'll do the 2 presentations first, back to back, and then we'll take our questions. By the way, when I look at my questions from last class, I saw that some group members didn't get to ask their questions. Please, guys, don't throw away your 5% out of your 20% grade. After the presentation is done, at least one member from each group must pose a question to the presenting group. That's it. Any question? All right, guys. Remember, the questions are not to you're not testing how much the presenter know. What you're doing is you're asking questions to find out maybe a little bit more, to expand a little bit more on what is presented. So we'll have group 1 now. Group 3 now, and then group 4 that has topic 4, right? You will have rapid prototyping after. All right, so let me stop my share. And you can take it away, group 3.
Okay, good afternoon, everyone. Can you hear me?
I can hear you loud and clear.
And you can see, right?
Yep, I can see
Okay.
loud and clear.
Okay, good afternoon, everyone. We are group 3, presenting on topic 3 on a comparative analysis of 3D modeling software. In this group, we have Kristen Irons, Alana Graham, Jenny Johnson, and Gifford White. The 3 softwares that we will be investigating and comparing are 3ds Max, Blender, and SketchUp. So a few things that we will be going through in this presentation is industry application, cost, system requirements, compatibility, functionality, pros and cons, and more. Enjoy.
Morning, thank you for watching. My name is Gifford White, and I'll be giving a definition of our software. So, SketchUp. So, SketchUp is a versatile 3D modeling software that was developed in the 2000s. It was acquired by Google in 2006, and then it was later sold to Trimble in 2012. It is widely recognized as a very good tool to push and pull generic models. My apologies.
Okay.
SketchUp comes in 2 versions. So you have SketchUp Made, which is a free option for personal use, and also SketchUp Pro, which is a pro version that is paid for, and it gives you access to most of the professional applications that comes with the software. Next slide, please. So we're talking about Autodesk right now. So Autodesk is a multi-application software, and it was founded by John Walker, and it was co-created by Flagship Products. So AutoCAD is widely used by many professionals, especially in the architecture, construction, and engineering industry, and it's also used for the manufacturing of products and product designs. It's also mostly used for the detailing of 2D drawings as well as the modeling of complex 3D models. Next slide, please. So 3ds Max. So 3ds Max is one of the applications that is offered by Autodesk. 3ds Max is a 3D graphics computer software that was introduced in 1996, and it became the industry standard for modeling and animation and also rendering. It uses polygon rendering, which is very good for persons who are in the field of game design, as that gives the creator very versatile opportunities to modify and control each different polygons. It's also good at material applications. Next slide, please. Blender. So Blender is a free software. It's open use. It's used for mostly like 3D creations. It's also used in product design, as you can see for the example there. It's design of a sweatshirt. And what's good about Blender is that you can then take this design and send it straight into manufacturing. So that's one of the good things about Blender. Next slide, please. Thank you very much. That is the end of my section. And I will now hand over to the person who is doing the functionality.
Functionality. Now, what does this cover? Functionality refers to what a software or program or tool can actually do. So as it pertains to its range of operations, features, and tasks it can perform for the user. And the first thing we'll be tackling is modeling. And we'll be looking at the 3D modeling capabilities. Now, this refers to how well each program lets you create and edit shapes from simple boxes to complex detailed buildings or objects. For 3D Studio Max, it offers advanced tools for both simple and highly detailed modeling. It includes freeform and organic shapes. You can create everything from basic walls to intricate curves and custom details. It also supports mesh and surface modeling, which means you can design smooth, realistic forms and optimize them for rendering or animation. It's also great for large, complex scenes and detailed environments. On the other hand, Blender also supports complex modeling with tools for both hard surfaces like buildings and organic shapes like sculptures. It has a feature called a geometric nodes, which is used for parametric modeling, which lets you set rules or patterns that the software follows to build shapes automatically. And it is good for creative and experimental designs, and it's also free to use. For SketchUp, it focuses on simplicity and speed. It has a push or pull tool, which lets you quickly turn flat shapes into 3D objects. It's best for basic to intermediate modeling, and it's ideal for early design concepts and quick studies. It has a huge library of ready-made models, which is found in its 3D warehouse. So you can easily add furniture, trees, or other elements to add to your scene. We'll now be taking a look at a short video which will allow you to visualize the workflow. I hope you were able to see the workflow I was speaking about. So the meshes, the push and pull techniques, the geometric nodes, and we'll now be moving on to design tools. And this refers to features that help architects design buildings, organize projects, and automate repetitive tasks. For 3D Studio Max, it includes automation tools like something called MaxScript, which can speed up repetitive tasks. It has advanced material and lighting editors, which are important for realistic visualizations, and it offers tools for organizing large projects and managing complex scenes. For Blender, it has add-ons like Archipack for creating walls, doors, and windows quickly. It also has geometry nodes, which allow for procedural and parametric design, which is useful for generating patterns or repeated elements. And it is really good for experimenting with creative architectural forms. SketchUp is a very intuitive interface, which makes it easy to start designing right away. It has plugins for architectural tasks like V-Ray for rendering or Profile Builder for custom components. And it has Layout, which is an interface which is integrated into it, which lets you create 2D drawings and presentations directly from your 3D model. Rendering and visualizations. Now, this pertains to turning your 3D model into a realistic image or animation, and it would show materials, lighting, and shadows as they would appear in real life. Now, 3D Studio Max is known for high-end photorealistic rendering. It supports powerful engines like V-Ray and Arnold. It uses advanced control over materials and lighting for lifelike results, and it is used for professional marketing images, client presentations, and animations. Blender has its own built-in rendering engines, Cycles, and Eevee that can create very realistic images and animations. It allows for detailed control over lighting and materials, but requires more learning to master. It is great for producing high quality visuals and especially if you want to experiment with creative effects or animations. Now, SketchUp has basic built-in rendering, but most users rely on plugins, like I said before, like V-Ray or Inkscape for those photorealistic results. It's easy to set up with simple visualizations, but not as strong for advanced lighting or material effects. But it is best for quick, clear images which communicate design ideas rather than high-end marketing visuals. Animation. Really close to rendering, this refers to the ability to create moving images like walkthroughs, flyovers, or animated elements in your design. 3D Studio Max offers advanced animation tools, including character animation and physics simulations. It is great for creating professional walkthroughs and animated presentations. Blender has a full animation suite with rigging and character tools. It supports simulations like cloth or fluid, and procedural animations. It is good for both architecture walkthroughs and creative animations, while SketchUp has basic animation capabilities, mainly for simple camera movements or object animations. It is focused on architectural walkthroughs rather than complex animation. We will now be looking at a short video again to compare each of them so you can see what the rendering slash animation will look like for each software. All eyes is on me. Won't tell no lies, won't hold my tongue. Don't cry for me. This Chicago. Documentation, really important in our industry. It refers to creating 2D plans, sections, and elevations from a 3D model. 3D Studio Max has limited 2D documentation tools as it is mainly focused on 3D work, but it can export to CAD formats for further documentation in other softwares. Blender also has limited 2D documentation because it is also used mainly for 3D visualization. But like 3D Studio Max, it can also export to other formats for documentation. SketchUp has strong integration with Layout, which is a partner software which allows the creation of professional 2D drawings and presentations. It also automatically generates 2D views from your 3D models with tools for dimensioning and annotation. And we'll now be looking at use of this.
Now let's talk about the ease of use for these three software tools. Starting with 3ds Max, this program is the most challenging to learn. It's built for professional grade 3D modeling, especially when it comes to creating highly detailed and organic shapes. While it gives designers full creative freedom and ability to produce photorealistic renderings, beginners often need a significant amount of time to get comfortable with its complex interface and tools. It's powerful, but definitely not beginner friendly. And that's why we gave it 2 stars over here, which is the hardest. As students, we're not really looking for the hardest one. Moving to Blender, this software sits in the middle in terms of difficulty. Blender is a free, open source program with a wide range of features for modeling, animation, and rendering. While it's more accessible than 3ds Max, it still has a fairly steep learning curve because of its extensive toolset. With practice, however, users can unlock its full potential, making it a great long-term investment. 3 stars in the middle, very moderate. Moving on to SketchUp, which is very beginner friendly. It is considered the easiest to use. It's popular among architecture students such as us and beginners because of its straightforward, intuitive interface. Many people start with SketchUp when learning 3D modeling since it's designed to be simple and approachable, even those with little to no prior experience. So we gave it 5 stars on the scale. Additionally, some other things that are done on these 3 softwares for 3ds Max are architectural visualization, game asset creation and development, film and VFX production, animation and motion graphics, products and industrial design, virtual reality and augmented reality environments, and interior design and set visualization. On Blender, similar to 3ds Max, architecture, animation and film production, VFX, game development, product and industrial design, VR and AR as well, scientific visualization and education, and art and digital sculpting. Lastly, on SketchUp, architecture and building design, interior design, landscape architecture, construction and engineering planning, urban planning, furniture and product design, and 3D printing and prototyping.
Compatibility. Now, this is how well a program can work with other systems, softwares, hardware, or environments. As architecture students, it is really important for us to know this because we often jump from one software to another. Now, we will be looking at file formatting, and this is which file types you can import and export, which affects how easily you can share your work and collaborate with others. 3D Studio Max. 3D Studio Max supports a wide range of file formats, and those include PWG, DXF, FBX, OBG, and STL, and it works really well with other Autodesk products since it itself is an Autodesk product. Blender. This supports major file types, OBG, FBX, STL, DXF, and it can connect to BIM and CAD workflows using add-ons. It's an open source, so new formats are often added by the community. SketchUp is very good at importing and exporting files, especially with AutoCAD, PWG, DXF, and it has a native SKP format, which supports STL, 3ds, and other formats. Operating system. Now, this is about what kind of computer you need and which operating system the software runs on. Now, for 3D Studio Max, it is Windows only, and it requires a powerful computer for large projects and high-quality rendering. Blender runs on Windows, Mac, and Linux, and it works on a wide range of hardware from basic laptops to high-end workstations. SketchUp is available for Windows and Mac with a web-based version and an iPad app for mobile modeling. There are 2 slides, BIM and CAD, and I'll be combining them both and speaking about both of them. So BIM and CAD integration. BIM stands for Building Information Modeling and CAD Computer-Aided Design. And this integration is about how well the software works with industry standard tools for construction and engineering. 3D Studio Max. 3D Studio Max integrates smoothly with Autodesk BIM and CAD tools like Revit and AutoCAD. It can import and export files for use in BIM workflows, as we looked at before. Blender can import and export BIM files using add-ons, but integration is less direct than with Autodesk products. But it is good for creative modeling, even though it is not a full BIM solution. SketchUp. On SketchUp, you can import and export both BIM and CAD files, especially with the use of plugins. It is good for early stage BIM work and sharing with other persons in the industry, like engineers, etc. The plugin ecosystem. Now, these are add-ons that expand the software's features like advanced rendering, modeling tools, and analysis. And we would have looked at how plugins play a part in each of the subtopics we have covered thus far. For 3D Studio Max, it has a large commercial plugin market, including V-Ray, Corona, and many others for rendering and modeling. Blender is an open source with a growing community of free and paid add-ons for architecture rendering and more. So you can find almost anything there. For SketchUp, we have been looking at different plugins that you can be using for SketchUp. It has a huge extension warehouse with thousands of plugins for rendering, modeling, analysis. Almost anything you think you can't do on SketchUp, you can find a plugin for. We'll now be moving on to the system requirements. For system requirements, we would have looked at that a little bit before as it pertains to the platform support, and we can see more specifically what we would need as it pertains to the lots of requirements for each of the softwares. Now, for 3D Studio Max, you will need an extremely, well, not extremely, but it requires a powerful computer, especially if you're going to be doing large projects and high quality renderings. Blender, as you can see, works on a wide range of hardwares from basic laptops to high-end workstations. And SketchUp, it is a little bit in the middle for both of them. So if you have a middle-level laptop, it will work perfectly fine for that.
Okay, so in terms of performance, it generally refers to how well the software can handle increasing demands in terms of complexity, workload, and integration. So firstly, for 3D Max, it's known for its robust performance with multi-core CPUs, which makes it excellent for rendering, simulations, and certain modeling tasks. It can handle millions of polygons and highly detailed environments, making it ideal for complex urban scale models. Additionally, it manages large CAD imports smoothly, provide provided that the models are optimized so you rarely experience slowdown. Next up is Blender. So it can handle millions of polygons. However, extremely large scenes might put stress on the viewport, and massive CAD files or ultra-dense meshes may cause slowdowns or crashes if not optimized. Its real-time rasterization engine is optimized for interactive previews, look development, and real-time rendering, making it a versatile tool for both modeling and rendering workflows. And lastly, SketchUp is a lightweight and ooh, hold on. Oh, finally, SketchUp is lightweight and runs smoothly even on standard laptops and desktops, unlike some heavier CAD or BIM softwares. It scales well in workflow and functionality, but it struggles with very large or highly complex models. Unlike 3ds Max or Blender, SketchUp primarily uses a single CPU core for modeling tasks, which can limit performance in large objects.
Thank you very much. So I'll be touching on the industry applications. So the industry applications that you can find the software in are on the global industry, and of course in the architecture industry. So on the global industry, Blender and the 3ds Max are mostly used for game development. 3ds Max can also use for visual effects, as it can apply real world aspects to models such as gravity, wind, etc. And SketchUp is mostly used for concept designs, for example, in product development. as it relates to the architectural industry, SketchUp is used by architects, engineers, and also contractors. They can have one SketchUp model that all industries are collaborating on. 3ds Max is mostly used for visualizations of products before they move into other stages, such as design development. And Blender is currently growing in the architectural field, but it's mostly used for visualizations as well. So community and support for all these softwares. Most of these software has great support channels on YouTube. For SketchUp, you have SketchUp Master. In relation to YouTube channels, you have Kevin Steroids. Kevin is very good for Blender. He has some great tutorials here, as well as 3ds Max. So there's YouTube channels for 3ds Max as well, and there are also great support platforms such as websites. So Autodesk provides a support website for 3ds Max. Blender has its own support website on their official website, as well as SketchUp. Next slide, please. Thank you. So I'm moving over to the person who's conducting the task.
Okay, so for cost, which I'm sure all of us are interested in, because I know a lot of us don't want to spend an arm and a leg for these softwares when we're in school. So this is just a little comparative graph. I have the breakdowns on the other side for the monthly versus the yearly costs for these three softwares. 3ds Max, as you can see, costs the most out of all three of the softwares. Blender is free, but if you want to plug in V-Ray, which is one of its rendering softwares, you will have to pay for that. And SketchUp is not free either. You would have to pay for a monthly or yearly subscription. Here is just a quick price breakdown of each three. So 3D Max, there's monthly subscriptions, which go up to $235 US. These are all in US per month. Yearly subscription, $1,875 US per year. And 3-year subscriptions, US $5,625 per year. And these are the only three options that they have. But for this program, for the monthly subscription, some of the main features: full 3ds Max access, updates, support, etc. Yearly, same as monthly, but paid annually, often cheaper per month. And 3-year, lower annualized cost over a long commitment. For Blender, it is free, which is great for us. You know, we love the free things. So it's free. And then if you want to plug in V-Ray, it's $33 per month, which works out to $199 per year. And this includes advanced rendering capabilities, enabling photorealistic lighting, textures, and materials for high-quality visualizations. Lastly, for SketchUp, it is not free unless you are doing the web/iPad modeling, which has limited tools. I know we've all tried it when we try to get around having to bite. But there's also the Go, which is $19.99 per month, basically 20 US, $119 per year. And this is the web plus iPad version, essential 3D tools and cloud storage, etc. And then the plan, 100 US per month. And yearly, that would work out to $349 per year. And this includes desktop modeling, 2D documentation, enhanced interoperability, etc. And for Studio, there is no monthly cost. This is just an overall one. And that would be $749 US per year. And this is advanced visualization, BIM-related tools, extras like Scan Essentials, etc. So I assume that if you're in an architect firm, this is the plan that they will go for, just a year-long one. So now I will be touching on the pros and cons of each of these softwares. Starting with 3ds Max, This program is widely recognized as an industry standard, especially for complex 3D modeling. It's commonly used in game development, visual effects, and architectural visualization because of its powerful and flexible modeling capabilities. Another major advantage is its compatibility with a wide range of rendering engines, which makes it highly versatile for different project needs. In terms of Blender, on the other hand, has a completely different advantage. It's free and open source, making it extremely budget friendly, which as we look out for as students. It's especially strong when it comes to character and environment animation, as well as simulations like particle physics and rigging. Blender also supports game programming, making it appealing to indie game developers. Plus, because it's open source, there's a huge library of free tutorials and resources available to help users grow their skills, which Gifford listed a few in the previous slides. Finally, SketchUp shines in its simplicity and user-friendliness. It integrates smoothly with popular rendering plugins like V-Ray and Lumion, making it great for creating photorealistic visuals. It's especially useful for conceptual design and client presentations, where clarity and speed are important. Additionally, SketchUp provides specialized tools for structural and HVAC analytics, and its 3D warehouse gives users access to a massive library of pre-made models, which saves a lot of time in the design process. Moving right along to the cons, starting with 3ds Max, while it's a powerful tool, it does have a steep learning curve. For beginners, the interface can feel overwhelming at first. Another drawback is its subscription-based pricing, which can be quite expensive, especially for students or small studios. It's also not the best choice for early conceptual design stages and is more commonly used in industries like gaming and visual effects rather than in architecture, though that is slowly changing. Additionally, to achieve photorealistic results, you'll often need to pair it with rendering engines like V-Ray or Corona, which requires even more practice. On the other hand, Blender, it's free and versatile, but it comes with its own set of challenges. Like 3ds Max, it has a moderately steep learning curve, which can be intimidating for beginners. It's also resource heavy, meaning it needs a powerful computer to run smoothly, especially when working with complex scenes. On top of that, it can be time consuming to produce quick design iterations, making it less efficient for fast paced projects. Lastly, SketchUp, while very user friendly, has some limitations in terms of performance. Its native rendering capabilities are limited, so you'll need plugins for high quality renders. When working with complex models, the geometry can get messy and harder to manage. It's not as powerful for animations or large scale, detailed visualizations, and since its pricing is tiered, more advanced features come at a higher cost. So when you are picking these three, I want you to ask yourself, am I a beginner or a professional? SketchUp is best for starters, 3ds Max for advanced users.
Do I need speed or realism? SketchUp is fast, 3ds Max is ultra realistic.
Is budget a concern? Blender gives you powerful tools at no cost.
Do you need ammunitions? 3ds Max and Blender are stronger in SketchUp.
Do I work solo or in a team? Industry teams often prefer 3ds Max. Solo designers and freelancers and students might lean towards Blender or SketchUp. These are our references.
All right. Good
Thank you
stuff.
so much for listening.
Good stuff. All right. Great, great. Just a little bit on the borderline of being long, but very informative. All right, let's move into the other topic and then we'll go into the questions. So topic 4, you can go ahead and share.
Hello?
Yep, I'm here. This is topic 4.
Okay. Good afternoon, everyone. My name is LaShawn Cox, and my group and I will be presenting on topic 4, which is how is rapid prototyping technology used in architecture schools? So our objectives for today, there's quite a lot. So we're going to look at rapid prototyping, the major types, mainly focusing on 3D printing. So we're gonna look at the types of 3D printing, 3D printers, the finishes, equipment that would be needed for prototyping in architecture school, the software used, the file formats, the challenges. We're going to look at the major uses of prototyping in other industries and also in the architectural industry. We're going to look at the learning curve, major features, and we will also look at the quantitative and qualitative features of, I believe, not prototyping, sorry, 3D printing mainly, and some price comparisons.
All in
So
20 minutes.
yes, rapid prototyping. Rapid prototyping, for those who don't know, is a group of techniques used to quickly fabricate a scale model of a physical part of assembly using 3D dimensional computer-aided design data. Okay, cool. Moving on.
All right, so there are various types of 3D printers that are available on the market today. However, the three most popular ones are the FDM, which stands for Fusion Deposition Modeling. This is basically using thermoplastic filaments to create a plastic model from a digital file. An example of this is basically using this printer to create block models to use as a sun study or to get a rough cut of furniture to use to test proportions or ergonomics of a space. Next is the SLA, which stands for the stereolithography. It uses UV lasers to create a 3D object with polymer materials. Example is when you're doing your final model and you want to produce a precise, smooth, detail, and presentation quality model. Next is the SLS, which stands for selective laser sintering. This is using laser fused powder material to create a strong functional 3D model. Example is when you're creating a 3D model and you want it as a whole rather than various functioning parts. This is basically to test the durability of, let's say, an example being a louvered window moving as it is attached to the model on a whole. Next, going on. So there are in the industry there are different types of 3D printing. I went through the FDM, SLA, SLS. So moving to the digital light processing, this is similar to the SLA process. However, instead of using laser, a digital projector is used to flash an entire cross section at once. The MJF, which is the multi-jet fusion, this is used to create an entire truss system with precise joints. This is to test the strength of moving connectors. And last, we have the material jetting. This is basically an inkjet printer that prints an entire model with textures, colors, eliminating the need for painting and assembling afterwards. This is basically the creation of high-end realistic multi-material colored models. In 3D printing, the finishes are mostly matte, glossy, silk, and smooth, and there are examples of some at the bottom. Moving along. So equipments used in architectural school. So in order to set up a 3D printing station, you would have to have 3D printers. The cheapest ones are the FDM, the SLA, and the SLS. These, and from that you would have laser cutters. This is to cut the materials, whether chipboard, wood, or cardboard. You have the SNC rotors. This is basically cutting the thicker materials, whether it be in wood, aluminum, or more. And they have the plotter machine. This is basically a printer that generates 2D or 3D views of a design on a flat surface, mainly used for technical drawings, and you can use it on surfaces of wood or steel. The cost of these are a bit pricey. For 3D printers for school, they opt for these three one, which is the cheapest, which is ranging from 100 to 200,000. Laser cutters being from like 300 to 600,000. SNC routers from 400 to 800,000, and plotters being 200 to 400,000.
All right, so the software that would be primarily used in rapid prototyping would mainly depend on what means that you're going to be using for your modeling. So there are going to be three main types that we're going to be discussing, which is going to be CAD, model slicing software, and the CAM software. So CAD is going to be the software that you're going to be using to generate your 2D and 3D models, and you have different software that would be giving you more or less based on what you're trying to achieve with your model. So for example, like AutoCAD is very widely used, and it's somewhat of an industry standard that most people are accustomed to using that has light 3D modeling. Or you have software that would be easier to use, for example, SketchUp, which you can do really quick concept architectural designs, or to some extent, you can do more complicated designs, but granted, that's not the primary function. You have Rhino 3D, which is specifically for industrial design or architecture, and SolidWorks, that's good for mechanical and product design, as well as Fusion 360, which combines CAD and CAM, which we're going to be discussing later on. That has a wide variety of options in terms of integrating both the design aspect as well as manufacturing. Next slide. All right, so next we're going to be discussing model slicing software, which is specifically for 3D printing. So after you make your 3D model in CAD or whatever other software that you're going to be using, in order for the 3D printer to actually produce that model, it has to slice the model into layers, and we have specific software that specializes in this process, which converts the 3D model into instructions for the machine, which is G code. And again, you have a variety of different software that's more specialized for different uses, starting with Slicer, which is open source and highly customizable. And it has Pusha Sliceability, which is Pusha being a brand of 3D printer. You have Matter Control, which combines slicing and 3D printer control, as well as model editing all together in one package. You have Idea Maker, which is developed by Raise 3D, which supports a wide range of 3D printers. You have Repetier Host, which is also a free software that can manage multiple other slicers that were listed before. You have Simplify 3D, which is premium software that's more popular within the industry for use. And they have Kiss Slicer, which is Keep It Simple Slicer, which is your very lightweight and powerful option for more advanced users that would also be highly used in the industry. And you can see the diagram below, which show the transition from going from the digital model to the 3D printer. And then finally, we have CAM software, which is computer-aided manufacturing software. And this is mainly used for the CNC and laser cutter. So the difference between the CNC and the laser cutter being that the 3D printing is producing a model from like nothing, versus this laser cutting and the CNC, which is subtractive modeling, which we're taking the model out of an existing material, which results in the need for different software. So we have Mastercam, which is the industry standard for CNC machining, and it's very good in 2.5D and 3D and multi-axis milling, which is very good for applications where you have a more advanced CNC machine that has the ability to do subtractive modeling in more axes. You have Fusion 360, which mentioned before, combines the CAD and the CAM, really good for across the board for modeling and manufacturing. And then we have VCarve Pro, which is optimized for woodworking, side making, and engraving. And mainly woodworking would be really useful for architecture students, considering it would help us to capture the materiality in the models that we're going to be making during prototyping. So now the file formats that are used by all these software, starting with 3D printing, we have STL or stereolithography, which is the most common and represents the surface geometry of the 3D object. We have OBJ, which stores the geometry and the texture data, which is a lot more useful for models that are highly detailed that would capture the texture of like brick or wood or stone or whatever materiality that your model is trying to have. We have AMF, which is additive manufacturing file, which is XML based and supports colored materials. So if you have, let's say, a 3D model that is, let's say your model is has multiple colors and your 3D printer can facilitate printing in different colors, you can use this file format to, instead of printing in just one flat color, you're able to transition from like gray, which would be stone, to brown, which would be wood. And then you have 3MF, which is 3D manufacturing format, which is a modern alternative to STL, which is a lot more data dense and can contain more information. And then really quickly for CNC machining, we have STEP or STP, which is a neutral CAD format which supports 3D geometry. We have IGES, which is used to exchange CAD data between the different systems. We have DXF, which is a 2D vector format for cutting parts, mainly for CNC and laser cutting. Well, it can be used for CNC and laser cutting, as it's more 2D in nature. And then we have G-code, which is effectively the machine language used by the CNC and as well as the laser cutter, which can be generated from your CAD or your CAM software. And then for laser cutting, we have DXF, which is your, as I said, your drawing the same thing from the CNC. We have SVG files, which is a scalable vector graphics, which is a vector file format, which stores the 2D shapes as geometry, which can be applied to your laser cutter to get lossless, like save high resolution file images, as well as Adobe Illustrator and PDF files, which, depending on the software as well as the laser cutter, can be accepted, which would be easier for us as students to be using, considering we would have some experience with using Adobe Illustrator and PDF files from exporting our CAD documents. And then now the challenges that we would face in using rapid prototyping architecture really quickly. So we have the scale limitations. Due to the nature of rapid prototyping, the main limiting factor in terms of size is going to be the machine. So let's say you spend less money and you get like a 3D printer or a laser cutter that can only cut at a 200 by 200 millimeter area. You're limited to only working within that area. And if you would have to like cut something larger, you'd either have to get a larger machine, which would be more expensive, or in the case of 3D printing, you can cut your pieces to be smaller, like print your pieces to be smaller and then combine them in the end. You have material constraints with 3D printing where it can only really work with plastics, resins, and powders, which often would make it more difficult to capture the materiality of the model, specifically in architecture, or in the case of CNC and laser cutting, they're able to cut wood and they're able to cut wood, which is something that would be useful, but to some extent it's not that you can't get everything. And then you also have the high cost accessibility. Machines are expensive, time consumption for complex models, while it would be faster to build by hand. Sometimes it can be faster to do 3D printing, but it can take long to get your print done. And then the technical skill to convert from your CAD software to the sliced file in order to export it to your machine to get it made. That should be. All right, and then the ways that we can combine rapid prototyping and traditional prototyping, we can get really early concept models really quickly and then combine that with traditional materials that we could use. We could use the rapid prototyping to make our base, for example, 3D printed facades for the more complex geometry, and then use traditional to make it look nice and match materiality, as well as being able to get multiple iterations of your design. And once you have a promising design, you can continue and finish that design using regular hand modeling or hand sculpting based on what rapid prototype model that you settled on.
Okay. So now we're going to look at the major uses in the global industry versus the architectural industry. And for the global industry, we have 4 industries that we're going to expound on. So for the project development and iteration, it enables concept validation through the conversion of CAD files into physical models and for assessing aesthetics. The functional testing is facilitated using prototypes that undergo real-world valuations, identifying design flaws before they make like a mass production of it. And to add, when it comes on to design iteration, it allows engineers to quickly generate multiple versions of a part of the final project. For automotive and aerospace, a lot of persons nowadays, especially if you're very tech oriented, you will already know this, but for those who don't know, prototyping is normally used to create concept cars and also detailed prototypes aimed at design reviews and aerodynamic testing. So the intake, manifolds, and brackets are produced for performance assessment. Also for the tooling and the jigs and the fixtures, it allows rapid manufacturing and optimizes assembly line efficiency. For medical care, you can see prototyping used for prosthetics. It makes it more personalized and lightweight for patients. It also employs to produce patient-specific surgical planning modules for CT or MRI scans, which aids surgeons in like complex procedures. Also, expediting the development and testing of new medical instruments and diagnostic devices are done using rapid prototyping in the medical field. For consumer goods and electronics, this is basically, in short, their way of making a shell of the device for fitting or just for an aesthetic review. Moving on to the architectural industry. So in architecture, rapid prototyping, particularly 3D printing, serves several key functions. And for now, we're going to just look at these 4. So for architectural model making, which is the traditional core, it allows the creation of high detail scale models using BIM or CAD data, as mentioned before, enabling architects and also students to produce intricate physical representation of buildings, complexes, and urban areas. So practically, it makes detail, very, very easy, and also more efficient. For communication and client engagement, in short, this is where you can provide the clients and stakeholders with a tangible 3D model, which is significantly more engaging and can give them a more simple and easy comprehension of what's going on. For design validation and testing, rapid prototyping assists the feasibility testing by allowing for the creation of models to analyze specific engineering and environment concerns. So airflow or solar shading can be an example of that. It also supports constructability checks through large-scale models that validate the practical and safe assembly of complex structural connections on site. So practically, you're not going to waste your time and money for wonder if something is actually going to be able to be constructed. For our final point on the architectural industry, construction and full-scale application, the use of 3D printing specifically extends to manufacturing customized components such as unique facade panels and specialized formwork for concrete casting. Right now, there's a groundbreaking aspect of technology where there's an on-site 3D concrete printer where a large robotic printers are directly placed on the ground and they build walls, foundations on the construction site itself. And this application has been seen to reduce not only material waste, but also significantly decrease construction time.
Okay, so examples of works created by rapid prototyping. So first, there's a number of things you can do with rapid prototyping, specifically 3D printing. So you can make massive models to just get quick idea of what the form can look like at a specific scale or putting things in proportion. You can try and do facade details with might have complex parametric designs, panels and shading devices to do maybe like a sun study. You can try structural models as well, creating joints and actual load-bearing prototypes that you can actually test. You can also use rapid prototyping to create furniture and or interior elements to see how they would fit in a certain space or dimension. You can also use rapid prototyping like CNC to create certain sites and topography landscapes to see how buildings would fall on the landscapes. And also for like final detailed presentation models in kits and exhibitions. All right, so the learning curve for 3D printing and its softwares. So there's a few different layers to learning everything up to 3D printing. So starting off with the software, you would first have to learn like a CAD program like AutoCAD or Revit or Rhino. And then you'd have to get into like learning how to create your 3D models or your prototypes in those softwares. And then you'd have to learn the softwares such as the slicers, like like Cura slicer to be able to use those let your 3D model be able to be read by the machine and setting up the parameters like the layer heights, the infills, the supports, and stuff like that. And then there's also the learning curve for the machine itself. So the setting up of the machine, understanding bed leveling, loading the materials, calibrating, and stuff like that. So you might have a few challenges with initially learning the machine and dealing with stuff like cleaning the nozzles and warping. And there's also skill development over time as students continue to practice and troubleshoot their way throughout different projects and tests. So overall, you could say that it's a moderate learning curve that you can get over time. But as a beginner, you might face some issues in the earlier weeks, but it's something that you can get over time and projects. Okay, so some of the major features of 3D printing is that firstly, its ability to create precision and complexity in terms of its models. So you can use it to do complex geometries and parametric forms that would be a lot harder to be done by hand. The speed at which it can do this as well is another great feature of 3D printers as it greatly decreases the time needed in model making so that you can get more prototypes out. Also the scalability of your prototypes. So you can get you can print the same thing at different scales without having to redo everything from scratch. And you can also see how different things interact at different sizes with the same design. Also, the material that 3D printers use, it can help to create different type of finishes for whatever your prototypes are. So you might can get like a metallic type of finish, or can get a rough finish. So you have different materials to do that. Also the cost efficiency. So getting a 3D printer itself might be costly, but over time, after investing in one, it will reduce the price for model making as you spend less money on like manual labor, and you'd have a lot less waste of material from you doing that as well. It's also iteration friendly. So that's another big thing with 3D printers, is that it allows for designers to produce a lot of different iterations of their designs and be able to test all of them quickly so that you can come to something concrete much faster. And then also another feature is that its integration with CAD or 3D modeling software. It allows for whatever you model or whatever idea you have to be a lot more precise when it comes to the physical output of that. All right, so now describing like a typical workflow that an architecture student might encounter while trying to use rapid prototyping. All right, so first thing is the concept stage, where the student would have to come up with their initial sketch or concept design idea, and then they would have to start putting that in a CAD format and putting it into a 3D model and refining that 3D model. Then you'd have to prepare the file. So the file preparation to get it into a STL file or OBJ file that can go into one of the slicers software so that the 3D printer can read that file. And then there's also setting up that file inside the slicers, setting the layer heights, the infills, and the support scale and orientation, etc. And the next stage in that would then be to do the printer setup. So depending on the type of printer you have, whether it's a regular printer or a resin printer, you'll have to load the filament or the resin and do those initial setups. And then you'd have to make sure that the machine is pre-heated and the print bed is leveled and etc. Next, as the print starts, you'd have to continue to watch and monitor the print, watch for any form of warping, layer shifting, or maybe the nozzle might get clogged. So you have to make those adjustments. And then afterwards, when the print is complete, there is some amount of post-processing as well before you get to the final model. So if you're using like a regular printer, maybe you have to remove the supports or maybe assemble different pieces that you've printed. Or for resin printers, you might have to do some amount of curing of that as well.
All right, so now we'll look at some of the quantitative features versus the qualitative features of 3D design. So the quantitative features would be the physical and performance characteristics of 3D printers in architecture, while the qualitative features are the more experimental and impact-oriented aspects. All right, so some of the quantitative features include build volume, scalar capacity, printing speed, layer thickness, material disposition rate, material properties of output, energy consumption, and cost factors. So build volume would depend on the scale of the printers. So you can go as small as your typical desktop machines for like our architecture models, or you can go as large as robotic arms, cranes, and gantry systems that are capable of printing houses. Print speed is measured in either millimeters per second or meters squared per hour. Again, this would be ranging from our typical 3D models to the printing of houses. This print speed is also very critical for large scale construction efficiency. Layer thickness and resolution from our small scale of 0.05 to 0.3 millimeters in thickness to 5 to 30 millimeters thickness of concrete. This also affects like detail, precision, and it can affect the surface finish of your completed model. Material disposition rate, the amount of material exuded per unit time.
Mathnasium classes.
Go ahead. That's just my alarm.
Yes, so where was I? Yes, so layer thickness. So it goes from the thickness of 0.05 millimeters to 5 to 30 millimeters. And as I said, it affects detail precision and the finished surface of your model. Material disposition is the amount of material extruded per unit time, which can go up to as large as kilograms per hour. And material properties output, which is the comprehensive strength of your finished product. Energy consumption affects sustainability and operating costs. To operate a 3D printer at any scale could consume a lot of power, and that also power consumption would also feed into cost factors, which is not only the cost of the printer itself, but maintenance as well as the material needed to operate printer. Next. All right, so qualitative features. This is design freedom, your ability to customize and personalize your models, the flexibility of the application, sustainability impact, educational value, user experience, and accessibility, as well as the cultural and aesthetic contribution. So using a 3D printer, you definitely have the ability to go outside the box and explore your geometries and forms that you wouldn't necessarily be able to do with traditional means of model making. And it also aids in customization because 3D printing, you can produce unique and client-specific components without the additional cost or labor of trying to do these things by hand. It's good for prototyping and educational models, facade elements especially, and infrastructure, as well as it reduces a lot of waste as we all make models. So, we'll be wasting like PVC and mapboard and all of that, making all these errors in our cuts and such. So it reduces waste through that means. You also have the ability to create, as my group member said, more iterations of your work. It's easier to make changes and see how different things work. There's an ease of use with software integration. A lot of us are doing digital drawing via computer now, so it's very user accessible and it enables experimentation in artistic and architectural ways. A lot of us would probably be more creative if we didn't think that, oh yeah, this is a very pretty drawing, but to go actually build this model by hand might be very stressful. And thinking about that, we might simplify our artisticness towards our drawings. So 3D printing would aid in that. All right, so here's just out a video we're gonna watch. This is 3D printing on a larger scale. And just how it applies in, yeah, you can play the video. But just how it applies in the construction field.
My name is Ayman Hussein, and I am the Director of 3D Printing at Alquist. Here at Alquist, we focus on printing homes that are affordable in the community and for the people in the area. We range between 1,500 square feet and 1,300 for a single family. We use large-scale construction 3D printers to be able to create affordable housing in rural and unserved areas. So when we arrive on site, we typically work on a slab or a ribbon footing, and what we do is we set the printer up around where the house is going to go. We typically have around 5 or 6 pieces of equipment, and that is printer, and we also have a control panel to operate and monitor the print settings. Then on the material side, we have a silo which holds the dry material, but directly below that we have a mixing system and a pumping system. The water is added in that process and pumped through a hose, which then feeds the printer material. This process isn't very different than a typical desktop 3D printer. What you do is you start your design stage and you create a CAD file that basically tells the machine where to go and how fast to do it and how much material to let out at that specific spot. And so the program is the center line of where the nozzle is, and the printer will follow that line throughout the whole process. The way the printer reads, it's a cross section. So if you were to draw this up and you cut out a very thin line of that object, that's what the machine sees, and it sees a bunch of those over and over and over again to complete the house. The two rails, if you will, those provide your outer bounds for your wall. And so in that middle portion is where you can run electrical, your plumbing. In a sense, we are like a framing company. However, we're much more of a hands-on system where we construct all the walls and then we guide the GCs to install the doors, windows, HVAC, and plumbing systems. You're doing the house and you have to leave cavities for your two doors.
All right. So that's just a little look on how 3D printing is being incorporated in construction. Now let's do some price comparisons. So scale and there are a lot of variables that cause big swings when it comes into cost from between 3D modeling and traditional modeling. And really and truly, it boils down to what would work best for you, because in some instances, 3D printing would work out cheaper. In other instances, traditional modeling would work out cheaper. So it's just a matter of these factors that would eventually work out. So one of them is scale and the size of the model. So bigger models equal more material, which is longer print time, longer assembly time. If you have a smaller scale printer, it's going to take way longer than if you were to necessarily build a bigger model by hand. Level of detailing, fine detailing like windows and facade ornamentation, interiors. It demands more precise tools. So resin printing, or if you're a very skilled handcrafter, but with certain 3D printing, you will need more time for finishing, and this can increase costs heavily. Traditional materials to make models would be like wood, plastic, PVC, metals, glues, paints, and then you have your label to make it by hand. 3D printing is filament or resin or other supported materials, but then you also have the addition of post-processing. So you'd have to either sand it or paint it to get your desired finish. And resin tends to be more expensive per unit volume than the basic 3D printing filament. Labor and skill. Now, with traditional model making, you have to be, well, it's better, it will come out better if you're highly skilled in it. Intricate handcrafting can take hours. We all know that. We've all built models. 3D printing reduces the manual labor for repetitive precision work, but you will still need design prep with your CAD models and your 3D modeling software, as well as printer operation and finishing. So you would still have to keep an eye on the printer to make sure, everything is printing correctly. And then you would have to finish the model if the finish is not to your desire. Then the time turnaround. Time is cost. So traditional takes longer, and to do revisions in traditional modeling costs you more. 3D printing, it speeds up design and iteration processes in many cases. So there's a faster turnaround time, and that can yield savings as it allows for multiple versions. So depending on how big your model is, a model that takes maybe 8 weeks by hand can be done in 4 weeks by 3D printing. But again, that also depends on your how good you are or how skilled you are in dealing with the software. Irregular and complex geometry. It is way easier to do complex geometry via 3D printing than trying to do it traditionally. So organic curves and complex undercuts and stuff would be easier to do with 3D printing. Post-processing and finishing, even 3D prints, as I said before, would probably need sanding, painting, and if it's really big, you have to probably assemble certain pieces. So these costs can amount, especially when a high quality finish is required. Traditional models often need such work too, but there are different trade-offs when it comes to this. And then upfront investment versus recurring costs. Buying printers is a capital cost. So that's a big initial cost, but then you'll have to think about maintenance, getting the filaments, keeping that stocked. If it's something that is not available readily in your country, you have to think about shipping costs to get that there. Handcrafting might be cheaper if this is not something that is readily available where you are. And then in regards to like waste and fail prints, this can also add on to your cost. All right, so with 3D printing, there are basic computer requirements you need. There's a minimum versus a recommended for everything. So processor, your memory, your graphics card, storage, operating system, connectivity, as well as architecture specific considerations. So I feel like we're over time, so I don't know if I want to bore you with all of these, but there are requirements for your computer that you
Right.
need, but I feel like everyone should be good on that front because Sir so
Good.
graciously showed us how to get computers in the DDM. So,
Thank you. Mhm.
yeah. Next. Okay, so overall takeaway from reviews and criticisms is that 3D printing has matured enough that many architects incorporate it into their workflow, especially for models and some construction prototypes. Its biggest advantages lie in that it's able to do complex geometry as well as its flexibility with doing iterations and then presentation value. However, finishing and mechanical material, there's finishing as well as mechanical and material limitations, cost of entry, which would be cost to get a 3D printer, as well as regulatory uncertainty, and then print size plus assembly issues are real constraints for it. In many practices, the best approach is hybrid, using 3D printing for parts of a presentation and then traditional methods for other parts. And then the choice of printer, whether it's resin or FDM, build volume, open system, or closed versus closed ecosystem, matters a lot. And reviews often praise those that balance usability, flexibility, reliability, and support.
All right.
Yeah. So thank you guys for listening. Any
You're
questions?
wel-
It's open.
you're welcome. That's a lot of data.
Yeah.
All right, cool. Okay. So that was 3D printing. I should send you guys upstairs to Mr. Barr, who is actively creating a 3D printing. Did any of you check out the 3D printing space, by the way?
Is it
The
done?
Fab Lab? It's there physically. The printers are there. That's good. I think it's in the testing phase now. But have any of you seen it?
No,
No,
I didn't
sir.
know. I didn't know
It's
if we'd
by
have access to it.
Okay.
No.
it's
Yeah,
by the IT lab, that lecture room right there, I think.
right. Beside 4C10 right there. So, mm-hmm. Yeah, man. In there is painted and everything, and there are a few printers in there, and I think that the last there's somebody on site that's testing them. So yeah, and very soon it will be a part of the module. Like, imagine you're getting assignments that require you to print something in the lab. Yes, Leshan.
Oh, sir, I was raising my hand for the questions.
Oh, right. Okay. All right. Well, so right before we jump into the questions, let's bring up my notes here. So first thing is, I can see that I know that the topic of 3D printing can go very deep, right? And I want to give a heads up to what's it? Topic 5. You guys are next week. You guys are doing AI in architecture. Just like 3D printing, there are some rabbit holes that you can go down. Especially nowadays, everything is AI, right? So with 3D printers now, yeah, and all of that info that you presented was just on 3D printers. So rapid prototyping involves other things, as you mentioned. So with that said, your main challenge was how do you compress? How do you summarize? And I think that is one I could see that in some cases you did do that. In most of the cases, like I know that you use a lot of bullet points, which is good. Same thing for the group before. I guess I'm giving general comments. You use bullet points and then you kind of explain. Um, I think for 3D printing though, you had more data than visual examples. You did have visual examples, but you there are some other areas where you could have some um instead of a text instead of multiple text bullet point, imagine you have an image or a video as a bullet point, meaning that you're not playing the sound or the talking from the video, but you are the one doing the talking, so that way you can control how long you spend on a bullet point. You know what I mean? So I think that some of the examples could use some visual instead of text. Um, the last slide, I noticed that you gave a kind of overall. I like the workflow that you gave on the student that is considering to do 3D. Kind of the workflow that you'd have to take to do a 3D print. Um, it's a little tricky to imagine it. Being somebody who have gone through it, what you explained is correct. Like it is, from a research point of view, it is correct. All of the considerations are there, considering that you have some models are big, you have to break it down into little pieces and all of that. Um, but I think the challenge with that is kind of resonating what you're presenting with you guys that you're presenting to. I understand it already because I've done it, so I'm seeing everything that you're saying. But I think a big part of explaining that workflow is a lot of visual examples, right? Um, so I guess that kind of tied into my first point there with the visual examples. Um, but overall, it's like an extraordinary amount of depth that you did go into. Maybe in some cases too much, but generally, that's great. Types of, I also learned things myself. I knew about the types of printers, but there were two other types that oh, that's interesting. I never really knew about those other types. This was the SLS printer, right? Which, so I was kind of intrigued to hear about that one. But then again, as I said, I kind of heard about it from voice and text only. You know what I mean? Um, all right, so we're gonna keep it short because the rest of the time is there. Um, before we go into the questions, so please, guys, think about some of the questions you want to ask so that we can go through that quickly because we have two topics to reveal. Um, all right, SketchUp versus Studio Max versus Blender, and I see that um Gavin kind of was throwing in AutoCAD in that mix. Anyway, I think the reviews were very good. Again, you had a lot of data. Um, the TikTok videos were interesting. It does kind of give a good summary, I guess. You guys would have to tell me because I know of these software, so I can kind of understand what the videos are showing, but I don't know how well you guys kind of grasped it. the overall question that I ask myself is that if I was investing money in establishing an architectural firm or some kind of studio, design studio or something, and I ask you guys to tell me which of these software I should buy, I think that your presentation definitely gave me the information that would be very useful. So it was successful, and I like how you use the bullet points and did your explanations, kind of show that you kind of understand. The one part that I think is missing is almost like I wanted you to. You did a summary at the end, but it's almost like I would have liked to seen. You see those different categories that you had, pricing, ease of use. I don't remember all of them, but you had like about what 8 different categories, right? It would be good if you had assigned like points, because you had this nice comparative thing going on. It would have been good if you assigned points to each one of these and then you tabulated them at the end. So it's like you would say, okay, so based on our point system, if you were considering for use in this scenario, SketchUp would be best, or you know, or Blender would be best, and so forth. Because what you have is like you give a lot of points, but you kind of leave it to the audience now to kind of check up the totals. Okay, they said Blender was free, and they said Max would cost more, but they said that Max could do this better, and this one had more plugin. You know what I mean? You understand what I mean, guys?
Yes, sir.
Yes.
We
Right.
tried to do that with the questions at the end, but the table would have made a lot more sense.
Right. So that because at the end I think all three of them have some good merits. I like how you pull up that boy SketchUp, easy to learn, not much features, but then I love the one about documentation. SketchUp is very good at documentation. So if you needed your plans, elevation, sections, no problem, but the other two would be a problem. One of them is free, right? By the way, 3D Max does offer what do you call it? Independent artist tier now. So where you pay like the same price as SketchUp, but that's a long story. Generally, 3D Max is going to be like the most expensive one that's there, right? And yeah. All right, so that is just my quick overview of both of the presentations. I'm going to bring up my slide now, and we're going to take one question from each group in the audience. So you remember, only the groups in the audience should be asking the question. I know that Leshan hand is up already, so let me get my thing that I can keep track of who is asking the questions. Yeah, go ahead. Cox.
So we can start asking questions now.
Right. So just tell the group that you're from
Okay.
and which group you're asking to.
So I'm group number 5. I'm from group number 5, and this question is for group number 3. So let's say that I started a project in SketchUp. Can I move it to 3D Studio Max or Blender later for like a more advanced rendering? And if that is possible, what advice would you give me? Like, what should I look out for?
Great question. I can take that one. So yes, you can move a project from SketchUp to 3D Studio Max or Blender, and you can do that by exporting a model to a common file format. Remember those formats I spoke about before, the OBJ, the FBX, the 3ds, right? You'll export it using one of those file formats. However, you should be aware that there are some details that may get lost in translation, like the materials, the textures. They may not transfer perfectly, and you might need to do it over, reapply it, or adjust it in that new software. Also, you need to keep in mind that very large or complex SketchUp files can sometimes cause issues, or it's going to move really slowly when you're importing it into other programs. So you want to make sure you clean it up as best as possible, or try to keep the size of the file to a manageable size before you export it.
Mm, it sounds like you have done this already. All right. That's a good answer. I want to add to that as we're all learning. So let me see. Hold on. Before I do that, that was group 5, right? That asked the question, right?
Yes, sir. Group 5.
All right. Group 5, you have. So everybody in group 5 get that point, right? Because you asked that question. All right. 5. Okay. 5 and 5. All right. Yes. So that's a good question. What you want to remember whenever you're exporting and importing between software, you have that. See, the answer was export to a common format. So that means you go to DWG, FBX, and then you would import that FBX into the next program, right? So you would go from SketchUp to FBX, which by the way, you can't. You can go from SketchUp to OBJ, and then you go from OBJ into 3D Max. However, before you go exporting or importing between any software, and that does 3D, SketchUp, Photoshop, Word, PowerPoint, any software that exists on this planet, before you go to export and import, always check if there is native file format support. What do I mean by that? Meaning you can open an Illustrator file directly in Photoshop. You can open a SketchUp file directly in Max. So you don't have to export all the time. So always check to see if the software that if the software that you're importing into, look if it directly supports the file. You understand? So PowerPoint can open Word documents. I can't remember. Somebody need to check that for me and double check. But I know that SketchUp can. So I know that, um, for example, 3D Max can open SketchUp files. I know that SketchUp cannot open 3D Max files. In that case, you'd have to go from 3D Max to OBJ and then so forth. All right. All right. Dushan, what group? And who you asking?
But sir, I'm in group 4, so
Group
I'm
4.
asking group 3.
Group 4. Got you. Okay, go ahead.
Yeah, so I wanted to ask, like, because they mentioned how like professionals prefer to use like 3D Studio Max in comparison to like Blender and SketchUp for visualization. So even though like Blender and SketchUp are like comparatively easier to use, why is it that professionals prefer like exactly 3ds Max over the alternatives?
Interesting question. I should give your group double points for that question, but my formula won't take it, so.
Well, Deshaun and
Oh,
my other
okay.
group members can put in to answer this one, but I feel like they choose that one, even though it's more expensive. 3ds Max is more compatible with like game engines and rendering software and CAD imports and all of those stuff. So, and just the quality overall, I feel the quality, it's what you're paying for, honestly. So, yeah.
Okay, that's a good answer. Any of your group members want to expand or? Quick question.
Oh, I'm not sure if
Oh, no, go
sorry.
ahead. Go ahead, Alena, and then I will go
No,
after.
I was going to add, I was just thinking a while ago, but I just want to add that professionals usually use Visual Studio Max or choose it because it's an industry standard for high-end architectural visualization. So that's one of the reasons why they would prefer to use over the others. If you guys remember that little comparison we showed you with the renderings and animations, you will see that 3D Studio Max, it looks really, really nice. So because of that, they choose to use it over the others because it just looks better and it's better for them.
Yeah.
Okay, fair enough. I wanted to draw back for something that was presented in the last presentation. Remember, there was a comparison between real time and offline. And one of the conclusions that I presented from that is that nowadays, everything look good. You understand? Twinmotion look good. Well, all right, fine. SketchUp don't look as good as Twinmotion and so forth. But if you throw the V-Ray in SketchUp, then yeah, man, it look just as good as the V-Ray in Max. You know what I mean? So when you say quality, it's like a gray area, right? Um, the funny thing is, like in all the CSA curriculum, we're not teaching Max anymore. We used to teach it, right? But we're not teaching it anymore. There are a few places that I have worked, right? Both local and abroad. And in the architectural firm, some of them will use Max, but usually you don't really see them using Max that much. It is industry standard. And it is what you call, quote unquote, a professional tool. But the thing is, guys, for the same reason that when you guys are leaving architecture school, you don't end up usually learning 3ds Max in a typical architectural course because it is a more complex software. You find that people are teaching SketchUp, Lumion, Twinmotion, and you find less of Blender, 3D Max, and so forth. However, what 3D Max and Blender gives you, these kind of more complex programs give you, are options. And when I say options, I'm not just talking about options in terms of the animation that you produce or the image that you produce. I'm also talking about options in terms of what you can create, right? So one of the feedbacks that your group gave was that, oh, you can create these really complex models somewhat reasonably in Studio Max versus if you try to create that complex model in SketchUp. It might be doable but very difficult. You have to jump through some hoops. So this program provides more complex tools, which is a good thing. But what you find out is that for what you call traditional architecture, traditional meaning, okay, you need to do some concepts, you need to present some kind of visual of what your concept looks like, and then you need to produce drawings. You find that you don't need some of those very complex options of 3D Max to do that. So that is why 3D Max is being slowly kind of moved out of the, I want to call it, traditional architectural workflow, and in comes these more simplistic visualization software. Now, it doesn't mean that you shouldn't use 3D Max. I personally use 3D Max, and there's an advantage for using that. You can create way more, you have way more options. So, another thing is, let's say that your design has a very, it's a building that transforms. You know, you're doing this awesome building that it's like a transformer, you know, like that movie. And the building can transform from a hotel into a, I don't know, a garage or some crazy thing like that. Like those concepts, you can't even think about building those things in, I don't know, SketchUp or whatever. You would need a way more robust tools to the things that is more complex. You understand? So that is where the professionals that use 3D Max have been pushed to. They are being pushed away from the norm, you know, the typical house and the typical townhouse, you know. We can use SketchUp, we can use Twinmotion, we can use Lumion. But then when you go to something that is more edgy, pushing the boundaries of architecture now, you find that you have to go to these programs with more complex tools. right? So that could be one of the reasons, even though professionals choose it, is almost like only some professionals would choose it. You get what I'm saying, guys? Or else you guys would all be using Max. Do you want to use Max, Miss Spence? We could do Max in 3D modeling, you know. What you
So
say,
I
John?
figured we just be starting with something easier.
A good answer, Alila. Right. We actually used to do it, by the way. But we don't do it anymore. Right.
Is it
So
because it was too hard to use
not hard.
or not as
It
beginner
was
friendly, per se?
That's a good one. That's a good one. Beginner friendly. And some of those options that Max gives you, I would say, as I said, traditional architectural kind of design, like you could get those same options with a simpler software, right? Um, Crap, running out of time. I don't want to linger too long on this topic, but there's stuff to learn. Another big use of why you would use Max. So, for example, oh, I'm not sharing. Let me share my screen real quick. Um, Let me try and give you a quick example really quickly. Okay, are you seeing? Yep, I'm sharing now. Right, so what's the easiest way to do this? I'll just jump to my website real quick. Minimize that. Okay, there we go. Ooh, I have too much windows open. Okay, here we go. All right. We go browse. Okay, so for example, let's go to guy here. And let's say something like maybe this, right? Let's say something like this. And we're talking about visuals, not necessarily modeling now. But if you wanted to create something that's much larger, like a 20 plus story building, it might be a little tricky to use SketchUp alone to do it because you don't have the tools to. You guys had presented on when you have complex models. So more options mean that you have more ways of dealing with complex models. So if you have a building and each one of these rooms have a very detailed, potted plant, and there are 150 rooms in here. I mean, in SketchUp, you can't just copy the potted plant 150 times. You would crash your computer. It's not practical. But let's say you're using a program like Blender or 3D Max now, and they have a special system for dealing with complex shapes where when you copy it 100 times, it changes the nature of it so you don't crash your computer. So you can have 5,000 of these and you can still render your scene. So that's another example when I say more options. There are some projects that require more options to build and some that doesn't. So if I just needed to do a very simplistic building, maybe like this one, then maybe no problem, I can build this in SketchUp or whatever. But when I try to do something that's more complex, more large, that has more detail, maybe like this one, then I'm going to need more options to build it. All right, so that was just a quick example. All right, so that was group. So next question, 3 more questions. No, sorry, not 3 more questions. 2 groups presented, so 6 more questions.
Quick one for me, sir.
Yeah, go ahead.
Group 6. As it relates to the 3D programs, which one would be most suitable to convert to working drawings or construction documentation?
Oh, no, that question, don't answer that one because that one was mentioned. What group is that? That's group 6? You said you're group, yeah, from group 6, right?
Yes, sir.
All right, group 6. So here what group 6, if you want me to give you your point, you have to answer, somebody from your group have to answer that question. Because the answer was given.
Slackness. If you had given the answer, it probably was just passed over. Passed over. That's it.
All right, fine. So quickly, go ahead and answer this one.
My group?
Yeah.
Oh, personally, I say Blender is excellent for 3D modeling, rendering, and animation, but
No. The best, you said the best for architectural document production. That's what you said, right?
Right, for 2D drawings.
Right.
1000% SketchUp.
I was just going down
Yeah,
and
man,
breaking down
SketchUp,
because
man.
I
Yeah,
was
man.
about
Oh, she was just breaking it. Oh, okay.
Yeah,
Because I was
okay.
about to say
So
that.
SketchUp, yes,
comparing and
SketchUp.
contrasting. You know, it's in our nature.
Yeah, man.
Right.
Shady, man. Yeah,
But
man.
SketchUp and
Yeah,
layout,
good use, man. Yeah.
SketchUp with layout is
SketchUp.
definitely
Right.
where to go.
I like how the
Because
team
remember
does.
that Blender and
3D
Max don't really have the capacity for the
That
2D
is
Right.
I was
very
going
true.
through that, sir.
All right. You were going there. You're going there. No problem.
Thank you.
Right. So as I said, that was said in the presentation. So group 6, you barely scraped through with that because that would mean that
You can give them the point, man. You can give them.
Can give them the point. All right, cool.
Give them the
Yeah,
point.
man.
All right, next question quickly. Because we're running out of time here now.
Yeah, just a quick question from group 7. You mentioned that Blender is free. Can you confirm if 3ds and SketchUp have free trial that you can cancel anytime without charge to your account?
Okay, hold on a second. 7, 8, 9, 10. Yeah. Oh, okay. So this is the last question for this group. So every other question now has to be the other group because this is the 4th question now for this group. So yeah, go ahead and answer the question. Topic 3.
Okay, I'm glad to answer this one, and I'm glad that we get so much questions. That means we had you guys engaged, and we're happy to answer them. So for SketchUp, you can use the free SketchUp on the web, but the tools are very limited for that one. I'm sure you tried it before, when we had to do the SketchUp for this class, Introduction to VDM, I think it was.
Right.
And we tried the online one, but the tool set was very limited. So you get a 1 month free trial on SketchUp. Blender, as you know, is free. And 3ds Max, it's not free, but I think Sir had mentioned that there's a new
tier.
Yeah,
there's a new tier, but
yeah.
it's only available in some countries, so
yeah,
ignore it.
Well, and it would definitely not be in Jamaica,
But you
We're
can
not
use you can use the good thing about
A VPN.
Autodesk. No, the good thing about Autodesk is because they're big, they have free student license, so you can use it free technically.
Oh yes, because the 3ds Max does come from Autodesk. So once you have a student ID, you can get that free license just like for Revit and AutoCAD.
Exactly. All right. So that answers that question on availability for SketchUp. There's another tip I want to add to that. SketchUp used to have one that's called SketchUp Make. And what happened is that SketchUp Make is under a kind of a license. You know that license that, let's say, is open source. So with open source, you can't charge for it once you make it free. At least you can't charge for that version. So that version still exists, but they hid it. So Trimble doesn't make it possible for you to actively find where to download SketchUp Make. SketchUp Make is better than the web SketchUp, definitely way better, but it is not as robust as SketchUp Pro. But Trimble is not like you see this button on the website that said download SketchUp Make. So you have to Google it. You'll find it. It still exists there. I think then go up to like version, I don't remember, but it's still there. So if I wanted to use a free version of SketchUp, I would look for the SketchUp Make. All right. I think I gave you guys that from DDM. I still have it somewhere stashed away. All right. Next question, quickly. It's 5 o'clock. I mean, it's 4 o'clock. Do you guys have a class right now?
All right, sir. I have one question for the 3D printing group, right?
Okay, go ahead. Oh wait, tell me, what group are you from?
From group 2.
Oh, hold on a minute. I didn't have my Zoom up. Am I going according to where's the Zoom window? According to who raised their hands? I'm sorry if I wasn't. Okay, all right, go ahead. Let's go ahead.
All right, so as opposed to 3D printing, I saw they had a video of like basically them 3D printing a house. I was wondering if that's more cost effective than actually building a house, or the advantages of that.
Okay, that's a good question. Go ahead.
All right, so good question. So when it comes to it's a give and take. It would be cost effective in the sense of it saves you from like manual labor in regards to you won't have to hire as many workmen. It's also in regards to materials, as you wouldn't have to necessarily buy cement blocks and stuff, steel and stuff. So material is different. The materials you have to get is different, as well as I said, the reduced costs with manual labor, but it does have its own costs in regards to get a 3D printer to that scale. That initial cost of potentially starting that kind of construction would be very great. So it's a give and take in regards to what you're willing to do. Something like that, if you're building a one house, I would say just do it the traditional way. But if you're doing it like how they build schemes, which essentially what they do with schemes now is formwork and they pour the cement in, then 3D printing the house may work out better than having to do all that formwork. As I said, reduces manual labor and such. But if you're building your house specifically, just go block, cement, steel, and you workman them, and yeah, that would probably work out cheaper than trying to get it 3D printed.
Yeah, that's a good answer. Yeah, also the other thing is availability, because that is primarily overseas. I haven't yet heard of a 3D printing house locally in Jamaica yet, but I'm sure it will eventually come. Right? So yeah. All right, cool. Good question. Abigail.
Yeah, sure. A question from group 8.
This is from 8. Okay.
Yeah. So we wanted to know if there are any specific materials that they use for laser cutting. Any materials that are best to use, or if there are materials.
Wait.
Okay.
You can only ask question 2. Oh, sorry.
Yeah, it's for the.
Yeah. You're correct. Sorry, my bad.
Yeah.
It's 3D.
Yeah.
Laser cutting. No. Yes, laser cutting. Yeah.
Yeah. So I wanted to know if there were any specific materials that are best to use, or they typically use, or like recommended. You know.
Yeah.
I can answer this question. So typically for laser cutting, more in comparison to like 3D printing, you're able to actually cut because it's subtractive. the material would have to be something that you can remove what you want to get from it. So best materials would be like balsa wood or basswood, or like wood-based materials. You could also do laser cutting from cardboard, which would be good for like your mass modeling. Could use matte board if you want to get something with color. And in terms of things I wouldn't recommend, there are certain materials that, because of the nature of laser cutting, you're using a laser beam and it's generating heat. So like, for example, PVC, which a material that's popular for us as architecture students, but it's something that can't be laser cut due to the melting of the plastic. It creates toxic fumes that can both deteriorate the laser cut and would be harmful to your health. So there are health standards in terms of what materials would be best for laser cutting, but overall, like, general best bet would be any wood-based or paper-based material. Those are generally better, and depending on how powerful the laser cutter is, you could even cut like steel or acrylic.
Right. Good answer. This is one of those ones where, as I said, like a video of the laser cutter would be good, because laser cutters, think about you guys know a pool table, right? So think about a pool table or half of a pool table. So it's very wide. I mean, you can get them smaller, but it's not going to be. It usually, laser cutters has not fully reached mainstream market yet. Like, you wouldn't go into a HP store and buy a HP laser cutter. You understand what I mean? But you would go into a HP store and buy a HP 3D printer. I mean, HP don't have 3D printers, I believe, but 3D printers has been, you can get them almost anywhere. Laser cutters are still mainly kept for industry. So usually those sizes are going to be pretty big. However, hold on, where's my, okay. You guys hearing me okay, right? I'm just making sure that, yeah, good. However, this is the 3D printer that I currently have. Well, not this one. I have this brand. I have one of these older versions. The new Bamboo, what's it called again? H2S now comes with, it's a regular 3D printer. It does, and also does laser cutting as well. 10-watt laser, which is not that, so you won't be cutting like a half-inch thick piece of wood for sure, but this could easily cut through balsa, and the size of it is pretty small. Like, it's not like a half of a pool table size, but it's like an all-in-one. So think about how you have an all-in-one printer that can scan and print and fax or whatever. The latest version of the Bamboo printer, which costs only $1,400, I mean $1,500, it can do both printing and cutting. So they are trying to enter laser cutting into the mainstream consumer, right? But of course, you can see that the price, I mean, you can get a 3D printer now for like $200, and this is $1,500. So obviously it costs more. But yeah, you can now go ahead and laser cut stuff with this printer, which is totally cool. I would love to get one. Maybe UTech will buy one for me. All right, next question.
Hi guys, I'm from Group 3. Now,
Okay,
I know
Group
that
3.
we're starting out only to 3D printing
Hold on.
big here.
Sorry. Group 3 asked question already.
No,
am I right?
didn't.
All right. So no, you're not supposed to ask questions.
Oh, we're not?
No, it's only the groups that are spectating are to ask questions.
Oh, sure. My group asked a question already too, so.
Exactly. But the thing is, you get the points for answering the question. You understand? That's how you get your points. But everybody else get their points for asking the question. You understand? Right?
No, I think you were saying his group just presented and they asked my group a question.
Oh, right. Hey, man, I understand
Yes,
what
sir.
you're
That's
saying
what
there,
I
so I understand what you're saying.
Well,
Right.
sir, technically, wouldn't they be the spectators for our presentation?
Well, actually, hold on. Did I miss that? The way that I have the calculation is that every other group, right? So it's supposed to be 9 groups. So it would be a little. So last week, I think group 1 didn't ask group 2 a question, and group 2 didn't ask group 1 a question. Right. So it's fine. I will keep that rule throughout the rest. All right. So the group who are presenting, you don't have to ask any questions. Both of you just have to answer questions. All right? Because a part of your of my grading for you is how you've answered the question. So no need to extra stress out yourself. You understand? All right. So that leaves group 1. I don't see any hands. So group 1 going once, going twice. Wow, we're going really over time here now. So I need to speed up, guys. So any other groups gonna ask any question? Going once, going twice, and it's gone. All right, good. So we are to unveil question 7 and question 8. I mean topic 7 and topic 8. Let me very quickly locate topic 7. I'm clicking as fast as I can because we are out of time. Big time. Topic 7. Topic 7. Topic 7. Come on. Okay. All right. All right. So topic 7 is gonna be, hold on, anybody from topic 7 here? Marvin, Addison? Is Addison here? I don't see Addison.
Yes, we're here, sir.
Okay, Marvin is here. All right, topic 7. The difference between presentation drawings, design drawings, and construction drawings. All right, so let me go again. Difference between design drawings, presentation drawings, and construction drawings. Oops. There's not even time for any drum rolls here. So this is topic 7. All right, cool. Here we go. All right, difference between presentation drawings, design drawings, construction drawings. All right, so you guys are in what? You guys are in 3rd year. So by now you would have known about construction drawings. We talked about that in 2D CAD, right? Well, not with me, but whoever you had with 2D CAD at the time. Presentation drawings is what you guys do all the time. The one that is tricky to explain is design drawings, right? And design drawings is so you might start off with presentation drawings. You take it a little further with design drawings, and then where you want to reach is construction drawings. So you can think of that step as step 1, 2, and 3, right? I want you to explain the differences between them, the nuances between them, all right? Why do you use each one, right? How do various types of software help you with these? So we've been talking about software for the last 2 weeks. What type of software would you use to do presentation drawings? What type would you use for design drawings? And what type would you use for construction drawings, right? So let's go. I want you to give me some scenarios that in where you use these types of drawings. I'm trying to ask a question without giving away too much because I want you guys to do the research. When do we use design drawings? What is the, when and why, right? When and why do we use construction drawings? Definitely, if you can find an example of a project in which there is presentation, design, and construction drawing for the same project, I think that would be awesome, because that way we could get to compare apples to apples, right? Not just a random example of a presentation drawing, random example of a design drawing, and a random example of construction drawing, but one where we can compare all three of them with one project. That's not too hard to find, right? And I want you to dive down and let me know those as well. Those are types of drawings that are produced in the architectural design process. So I want you to talk to me a little bit about the design process. You guys are in the architectural industry. If somebody come to you and say, Marville, I want you to design me a health center, right? When does each of these drawings come into play, right? Do you just jump and do some construction drawings? Do you do presentation drawings first? Like, I want you to try and paint that picture for me in your presentation. You know what I mean? Within the context of an architectural project. All right? All right, so that is this topic. All right. That wasn't far off, the icon, right? Every year I ask, every year when I reveal it, I ask your opinion on, did I adequately use a proper icon to hide the topic, but give just enough to pique your interest? So I don't know if Marvin, this did that for you.
Yep.
All right. And topic 8, right? Perhaps the most obvious topic, right? Who is here from topic 8? Swaby. Swaby is here, right?
Watson is here, sir.
But Watson is here. Okay. All right. Cool. And this topic is virtual reality versus mixed reality versus augmented reality and its application in architecture, right? So I want you to look on that topic, right? So, what did I press? I pressed something. Right, so, oh no, wait, crap. No, undo, that's not you. Where am I? You are topic, oh, virtual reality. Oh, okay. Oh, that was from a different year. Okay, all right. Let me find my tips for this one. So I tried to create these tips pages to kind of guide you guys in the presentation, because one of the worst thing is I don't want to give you a topic to do. Right, this is the right year, because we change up the topics every year. Right, I don't want to give you guys a topic to do and just send you out into the wild and then you come to me with all kind of stuff. I like to kind of guide you down that path, right? So virtual reality plus mixed reality plus augmented reality, right? So firstly, what are these three things, right? I think we have an idea what VR is. Some of us, anybody here mess with the Oculus? Oculus headset? Nobody? Anybody? Nobody play Beat Saber and these, you know, when you see like the crazy people jumping up and down playing stuff? No fans? Okay. Man, guess what? You know, we do this in advanced computing too. I'm going to try and do it again this year. I have some VR headsets. I normally carry them to class so that you guys can use it. You can't leave college and not say that you've experienced VR. I mean, VR was like the talk of the town a couple years ago. Now it's AI, right? So anyway, I'm sure you might have seen photos of it, right? So we kind of have an idea what VR is. But however, there's not just VR, there's two more. There is MR and AR, augmented reality, mixed reality. And I want you to tell me what is the differences between them, right? One of them, I know you wear a headset. Well, two of them you wear a headset. So what's the difference between the two headsets? What's the difference between the VR and the MR headset? And then the last one, you don't wear a headset. So what's the deal with that? So I want you guys to tell me the difference, define them. What kind of hardware do you need to experience these? What is the name of them? We know that the Oculus is perhaps popular because we use it to play video games and it's on the entertainment scene. But those other two are not on the entertainment scene. So what equipment is used for mixed reality? What is the name of that glasses or headset? What is the name of equipment used to do AR, right? I want you to give me some examples of how we can use this in architecture. Where do you see the future of VR and its impact on architecture, right? Do you think that you'll go into an architectural firm and everybody is wearing headsets, right? Do you think that we're gonna have a client meeting and they're wearing headsets? I want you to give me from a practical standpoint, because not a Hollywood standpoint. You get what I'm saying, guys? Practical, okay? And I want you to identify the pros and cons of using VR in the for architectural representation. I remember I was the marker for if you guys decide to do the master's course. I remember there was a person that did VR in architecture as their thesis project, and it was kind of interesting because these things sound nice when you watch it on the internet and all of that, but when you start to look into the practical use, you're like, I don't know. Do I see, give me a name of a lecturer. Do I see Miss Oti wearing a headset in my design studio class? Like you start to think of the practicality of it. I know it's hard to do it. VR is going to be very hard to understand internally. You can watch videos, but you will not understand it unless you try VR. As a matter of fact, what I'm going to try and do for you guys, I'm going to call Mr. Campbell, and you guys, if you really are interested, I can call Mr. Campbell and ask him to give you a demo of VR. I have some VR headsets. They are stored in Hope Pastures. I would have to figure out how to get you the key and access. But anyway, if you guys are interested to actually try VR, not necessarily just for playing games, but like to test it out in some kind of application, just contact me and I can see how I can work that out with Mr. Campbell to give you access to the VRs that I have next door UTech. All right, guys?
Okay, sir.
All right, cool. Because when you Google it and you AI it and all these things, you're going to get all fancy explanations, but you can test AR right now. I'm not going to tell you how, you do the research, but VR, you can only experience that. There's no way for you to know what it is, really. So I want you to look at those for me, the differences, and how do you see it impacting architecture? What about in architectural schools? For my design thesis project in master's, I had a VR experience, which was pretty cool. Do you think it would be used in schools? I don't know. The only way to really kind of know is you'd have to test it. So good luck with that. Anyway, guys, we're like 20 minutes over the time. And remember, guys, these are 15-minute presentations. I know I said 15 to 20. I'm not even saying 20 anymore. 15-minute presentations. All right, guys. As a final treat, I want to show you guys this video. I'm only going to show you the intro of the video because we are way over time. I think I closed it by accident. Hold on. This is for group 3 that did 3D printing. I specifically did not share this video with you because, oh, come on, try and find it. Printing. Okay, here we go. Right. Okay, here's an error. I wonder why. Let me try it in Firefox. Probably need to change my sound. It has something to do with Zoom and the share screen. Okay, here we go. All right. So, are you guys getting audio? Were you getting audio a while ago?
Play it again, sir.
Oops. Oh, stupid ads. Were you? No?
No.
Maybe I have to change it to this one. Let's see. Are you getting audio now? Were you getting audio? Okay, good. All right, here we go. All right, I'm only showing you the first couple seconds. You guys can watch it on your own. This was a video I had created on a tutorial for doing 3D. That's my sister. Well, they say from every disaster, there comes an opportunity to learn. So this is I call it my YouTube plant. I use it for decoration on my desk, which you would have seen from my previous videos. Now, I did manage to salvage the parts. I did tape it up, but I don't think it is quite camera ready because... All right, so basically what happens with this is that that was a little skit there. That was my little sister. She actually graduated from UTech, or graduating this year. Anyway, the idea was to recreate this vase here using a 3D printer. And I went through the process of designing it, printing it to go from the vase on the right to the vase on the left. This is a kind of a long intro video, and I kind of snip the different processes that we went through. So step 1 is to design it. Step 2 is to model it. I use 3D Max to model it. And step 3 is to cut it up in pieces to print it. And step 4 was to actually print it in the printer, right? So, so this intro video kind of goes through the different, just a quick explanation of 3D printing and the types of 3D printing, how to use it and so forth. And then at the end is where you have these really long videos that actually go through every minute of creating it. So if you guys I could see that from your presentation, you went down the rabbit hole of 3D printing. If you want to kind of check it out, it's not exactly an architectural model because it's a vase with an architectural theme. Eventually, when I have some time, I'll do another one for an actual model, like the ones I showed you guys. But if you want to check out that experience, you can check it out there. And my plan is to do more of these so that you guys do it using actual models from your design studio project. Hopefully I can get like a past student project and then do a 3D print of it or something like that. Anyway, I just want to leave you with that one little interesting video, guys. I will see
you broke your vase just for us.
just for a video, right? I'm telling you. Actually, if I'm being honest, I broke it not for the video, but just like how the apple dropped on Newton's head, when my vase broke, I was thinking of buying a new one, and I'm like, no, let me do a video of it. So I just asked my sister, who was here at the time, to say, hey, can you pretend to break my vase so that the video is not totally boring? And yeah, we did that little thing there. So anyway, guys, I'll see you guys next week where we will present. Next week we are going to present topic. Let's look on the website here. We are what now? We are on the 29th. So next week will be the 6th, and it's going to be topic 5 and topic 6. You guys are now up. And next week we are going to start checkpoint 3, which is the big one. I cannot iterate enough. This is the big one. This one is going to last at least 3 classes, guys. So use the time, finish up checkpoint 2. Remember, if you hand it in today, you get bonus marks. I think I inserted all the marks that came in already. You guys can check it out. Hold on, let me refresh. Let me see.
Sir, for that one, we're submitting the terrain it's not in that lineup that you had shown us, right? In that one right there, class participation.
Yeah, I updated it. So you're submitting foundation plus terrain. That's how you get this point.
I submitted it in coursework project separately.
It don't matter. It's the same thing.
Oh, so I don't need to resubmit?
No. Okay, I just put it here so you can keep track of what the activities were, right? So it's the exact, both of them linked to the same form. All right. So essentially, when you hand this in to me, if you hand it in today, I will mark yes with your ID. All right. Okay.
Yes, sir.
All right, guys. I'll see you guys. Oh, yeah, there's a question. Yeah, Joshua.
Yes, I was saying that I had to update my schematics design because it wasn't 2 floors. I tried to contact you about it, but I didn't reach you, so I'm just letting you know through here.
All right, cool. So just submit it.
Yes, I submitted. Yeah.
Okay, good. All right, guys. Sorry for going over time. Remember, next class, presentation 15 minutes. All right, I'll see you next week.
I'm sorry, we need to talk.
Oh, sure. You want to, the rest of you can go. You want to talk to me straight, or you need a meeting room?
Private, please.
Okay, no problem. All right, so I'm going to end the recording and then I will do that. So to everybody else, take care.